What's up, 7th graders? Unit 5, Lesson 2. Keyword today is proportions. So we are going to solve some proportions. And we're going to use proportions to solve problems as well. So we're going to get our proportional reasoning in today. Proportions to solve problems. So what is a proportion? It's a kind of like a relationship that compares multiple things, multiple numbers. So we're going to say it's a relationship. And really, when you think of proportion, I want you to think part to whole. So that's like what we're comparing. We're comparing part to the whole thing. Part to whole relationship. So as we look at kind of this key concept down here, two quantities, x and y, have a proportional relationship if all the ratios y over x for related pairs of x and y are equivalent. So what we got to do is we're going to look at these, so say our numerators. We're going to compare, let's call this our numerator 1, and this is numerator 2. So we're going to say, okay, numerator 1 over numerator 2, and hopefully that's going to be equal to if this is our denominator 1 and our denominator 2. So I'm going to put num 1 on top, which is 3, and numerator 2 on bottom, which is 5. And we're going to check to see, does it equal the same thing as doing, since I put 3 on top, I should also put 120 over 200. And so when I get down to it, we can factor out a 20. We can factor out a 40 from the number on the right here. And I'm going to end up getting 3/5 equals 3/5. So yes, they are proportional. You can also look at it as decimals. Okay, 3. Let's see here. What's 3 over 120? 3 out of 120 as a decimal equals 0.25. What's 5 out divided by 200? 5 divided by 200. That decimal point is in the wrong spot. You get the same exact thing, 0.025. So yes, it is proportional because again, I'm checking these different relationships and they all are I'm getting the same answer. I'm getting 3/5. I'm getting 0.025. So as long as I'm getting the same answers, I have a proportional relationship. Now we have a strategy to solve this, and we call it cross multiply. So my strategy is I'm going to take my two numbers that are like across from each other, and I'm going to multiply those together. And then I'm going to take my two numbers that are across from each other and multiply those. So really what I'm left with is I'm going to say, okay, I have 6 times x on one side and 9 times 4 on the other. 6x equals 36. The only way to get x by itself is to divide both sides, the left and the right, by 6, and I'm going to get x equals 6. All right, let's see if these are proportional. So again, if they're proportional, I should be able to compare my numerators to my denominators. I should be able to plug them in as decimals and see if I get the same answers. So I'm going to look first. I'm just going to say, okay, if I wanted to compare numerator to numerator and then denominator to denominator, I would get 4/10 is equal to 6/14. Let's see. Okay. Well, I could factor out a 2. So if I divide it by 2, that gives me 2/5. Could divide this one by 2. I get 3/7. Is 2/5 the same thing as 3/7? No. 4 divided by 6 as a decimal is 0.6 repeating. 10 divided by 14 as a decimal is 0.714 ... So these are not proportional. No. All right, if I look at these two, I can see, all right, 6/9, just because this is, excuse me, this is a very common one. I know that this is going to be 0.6 repeating as a decimal. So again, 0.6 repeating. And then 4/6 is actually 0.6 repeating as well. So again, if I were to compare these two to these two, could say 6/4 is equal to 9/6. This reduces to 3/2 and 3/2. So yes, they are proportional because I get the same answer. Last, again, I'm thinking, all right, I can maybe simplify 15/20. If I divided it by 5, I get 3/4. 3/4 is not the same thing as 5/7. I could try to multiply it by 2. There's no way I can get 6/8. No, that doesn't work either. So again, there's nothing I can do. I can't make this work. So no. Last example, if the relationship between the number of tickets sold and the number of relationship between the number of tickets sold and the number of hours proportional? If so, how many tickets were sold in 8 hours? So again, I have to check and I have to say, okay, in this case, we sold, looking at these numbers, 160 tickets in 2 hours. So between hours 3 and 5, that means we sold 80 tickets per hour, which is pretty good. But I also need to check that same thing over here. So let's say, all right, well, now I'm going to look at it from 5 hours to 9 hours. So that's 4. And then from 400 to 720, that's 320 tickets. So 320 tickets in 4 hours. 320 divided by 4 is going to give me 80 tickets per hour, which is the same thing. So that's great. So yes, it's proportional. So yes, 80 tickets per hour. And then they wanted to know how many were sold in 8 hours. So let's say after 8 hours, if we're at 80 tickets per hour, we would do 8 times 80, which is going to give us 8 times 80, 640 tickets. And again, that would be after 8 hours.